Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we get to continue our study of trigonometry, and we're actually going to learn something completely new. So we're going to still be applying the concepts we learned about sine, cosine, and tangent, but now we're also going to talk about the inverses of sine, cosine, and tangent, because we need those to solve for missing angle measurements. Right? Last lesson we were strictly solving for sides. Now we're going to be able to solve for missing angle measurements as well. We're going to skip the do now. That's just using the Pythagorean theorem and trying to simplify radicals. And let's look at the introduction right here. So it says, yesterday we learned how to use trig ratios to solve for missing side lengths in right triangles. Today we're going to figure out how to find a missing angle measurement using these two ratios. So let's look at the triangle from the do now. And you're going to pause the video and try to set up an equation using angle A and one of the trig ratios. So try to only have one variable, A, and see if you can set up a trig ratio based off of angle A. Okay, so might help to label the sides based off of this reference angle. 8 would be our opposite side, y would be our adjacent, 12 would be our hypotenuse, but we don't need the adjacent because that is not a... Oh, well, I guess you guys do have a value because you may have gone back and solved for y in the do now, but based off of the diagram we have here, we're just going to use the opposite and hypotenuse sides, which means we need to use the sine ratio, right? Because that's the ratio, the trig ratio that uses opposite and hypotenuse. So sine of A is equal to opposite over hypotenuse, so 8 over 12. Now yesterday, one of our variables was always in the ratio, right? It was either the opposite or hypotenuse side. Today, our variable is the angle. So we need to think about how do we get that A by itself? Because that's what we need to solve for, the A. Well, you may or may not have talked about inverse functions in Algebra 1. Depends, how far your teacher gets in the curriculum, but most of the time that really gets covered heavily in Algebra 2 or pre-calculus. So you probably haven't talked too much about inverse functions. Inverse functions, though, sort of act like inverse operations. So if I had an equation, let me just do this over here. If I had an equation like x minus 3 is equal to 8, right? We all know that to get the x by itself, I would add 3 to both sides. So I get x is equal to 11. Now, sometimes that variable is the input of a function, right? In the equation I just put up here in brown, the x was by itself. But it may be inside of something like a function f. So maybe you have f of 3 is equal to, not f of 3. Let's do f of x is equal to x plus 8. Or maybe you have, make this a little bit easier for you guys. F of x is equal to, we'll just say 10. Okay. Now, if I want to get this x by itself, I would have to apply the inverse function of x. That would undo my f. So to both sides, I would have to apply f inverse. So it's sort of like an inverse operation, except it's not like a addition, subtraction, multiplication, division, etc. You're applying an inverse function. And what this inverse function does, it undoes the original function. So I get x is equal to f inverse of 10. Now the x is by itself, and hopefully you could evaluate this side. Right? You don't know what the inverse function is here, so no, you don't know how to evaluate that side. But this at least shows you how to get the x by itself. So over here we do the same thing. We actually have an inverse sine function. And I'll just write this all new. So inverse sine, that's how it's read. It's not read sine to the negative first power. It's just read inverse sine. So again, you've got to apply it to both sides. Well, the nice thing is that this inverse sine and this sine function, they simplify each other. So I'm just left with a is equal to inverse sine of 8 over 12. And this can be solved or evaluated using a calculator. Okay, let's go ahead and do that. Let's go over to our Desmos calculator. Okay, so I just erased what we had on the screen, cleaned it up a little bit for us. Remember, this is a calculator. If you type in scientific calculator into Google, your first option will be this Desmos scientific calculator, and this will be sufficient for your work at home. Now you'll notice on the calculator right here, you don't see the inverse sine button, you just see the sine button. Well, if we go over here to this function tab, if we click on function and we click on inverse sine, we can then enter 8 over 12. I guess I don't need all those. They already have parentheses for me. There we go. If I click enter, this gives me the value of a right here. Now, we have to remember, a was an angle. So this is actually equal to an angle measurement. And again, we'll have to go and see what they asked us to round to, but we'll just round in the nearest tenth for now. So what we've just figured out, that missing angle in our triangle is approximately equal to 41.8 degrees. Let's go back to our notes and let's just sum up what we've learned about here. Okay, so again, what we've just found is that this angle is approximately 41.8 degrees. Now, there's actually 3 of these inverse functions, right? We have an inverse for sine, we have an inverse for cosine, we have an inverse for tangent. 2 ways of writing these. I am generally going to write them in this notation that I've underlined in red. However, there is another notation that I'll underline in purple, and this is just read as arc sine, arc cosine, arc tangent. It means the same thing. They're still talking about the inverse function. It is just a different notation. However, I will stick with the red in this class. In other classes, teachers may use the other one, but in this class, I'll stick with red. Okay, this is all the new stuff today. When we're solving for a missing angle, when we have that variable inside of a sine, cosine, or tangent function, we're going to have to use one of these inverse functions to get the variable by itself, to undo the sine, cosine, or tangent function. Let's get some practice in, though. Best way to learn. We're actually going to do 1 and 2. So in both of these problems, you were asked to find the measurements of all of the missing angles. So there's 2 in each problem. You will have to use trig for one of the angles, and then maybe you'll see the easy way to find the third angle. But for the first one, you'll definitely have to use trig. It is up to you which angle you find first. It is up to you which trig ratio to use, because there are multiple ways of solving these problems. Pause the video, take a few minutes, attempt number 1. See if you can find those angle measurements, come back, watch the explanation, and see if your way was correct. Okay, so again, you could have found any angle you wanted to first. I'm going to find this angle. I'm just going to call it x. Now, I am already given 2 sides of this right triangle, so I am just going to use those 2 sides. If you wanted to, you could find the hypotenuse, right, using the Pythagorean theorem, and then use that value, but why go through the unnecessary work if you're already given 2 sides? So we're going to use the opposite and adjacent sides to find the measurement of angle x. Well, the trig ratio that uses opposite and adjacent is tangent. So I'm going to have tangent of x is equal to 5 over 7.5. Now again, my variable is inside of my tangent function. So to undo that tangent function, I need to use the inverse of tangent. So I'm going to apply that inverse function to both sides. When I apply that, the inverse and the original simplify, and I am left with x is equal to the inverse tan of 5 over 7.5. Now, I am writing out this middle step in purple just to show you how the inverse tangent function works when you apply it to both sides. However, I don't expect you to write that out every single time as we move forward. You are free to jump from red to blue. I need you to understand what's going on between those two steps, but I'm not going to require you to write that out every single time. Okay. Again, I want you to understand, but it is a step that you can skip when you're writing it out. You can go over to your Desmos calculator. In fact, I will do that this time, just to make sure we're on the same page. Let's get rid of this. So this time I am doing inverse tan. Make sure your calculator's in degrees again. And we're going to have 5 divided by 7.5. And that means x, or that angle, is approximately equal to 33.69 degrees. And we will take that with us back to our notes. It does say to round to the nearest tenth, so we will change this. Measurement of angle A is approximately equal to 33.7 degrees. So we're just going to round to the nearest tenth. Now, to find the measurement of angle C, you could certainly use trig again. However, I think there's probably an easier way, and that's just using the triangle sum theorem. Right? I know that all three of these angles have to add to 180 degrees. So measurement of angle C plus 33.7 plus 90 is equal to 180. If I do some simplifying, that means that measurement of angle C, measurement of angle C is equal to approximately 56.3 degrees. And again, that's because we're rounding to the nearest tenth, so it's approximately equal to. Okay, instead of doing number 2, let's actually take a look at one of these word problems down below where we have to sketch our own diagram problem. And we'll finish off with that for this video. It's a little bigger. All right, so Baldwin Street in Dunedin, New Zealand, hopefully I said that right, is the steepest street in the world. It has a grade of 38%. To the nearest degree, what angle does Baldwin Street make with the horizontal line? I give you a couple of tidbits of information here. It says, note that a grade is determined by the ratio of the vertical distance to the horizontal distance. For example, 38%, for a grade of 38%, there's 38 feet covered vertically for every 100 feet covered horizontally. So let's just start sketching here and then see what type of trig we need to use to find the missing measurements here. So let's start by drawing the street. Maybe there'll be one video where that doesn't happen, where I'm able to go the entire video without having one of those random lines pop up. We'll see. So this is going to be Baldwin Street. Here's a right angle. And again, it says it has a grade of 38%. So that means that there's 38 feet covered vertically. So 38 feet for every 100 feet covered horizontally. Okay? And we're being asked, what angle does Baldwin Street make with the horizontal line? So our horizontal line, right, it's just the horizontal, it's this. Baldwin Street is the solid segment. So we are trying to figure out, we're trying to figure out this angle right here. Let's call it theta. Theta is just a variable we use for missing angle measurements. So think about what type of trig we need to use to find theta. Pause the video, see if you can figure it out, and make sure you round to, oh, it doesn't say. Oh, it does. To the nearest degree. Make sure you round to the nearest degree. Okay. 38 feet, that is the opposite side compared to theta. 100 feet is the adjacent side. So it looks like we should be using tangent again. So tangent of theta is equal to 38 over 100. Let me apply the inverse tangent function to both sides. That'll leave me with just theta on the left-hand side. And that'll be equal to the inverse tan of 38 over 100. If you punch the inverse tan of 38 over 100 into your calculator, as I'm doing that now, and these would never be something you would be expected to memorize, by the way. Theta is approximately equal to 20.8 degrees, but we are rounding to the nearest degree, so we would get 21 degrees. 21 degrees. Okay, that is going to wrap it up for this video. Again, main takeaways is that we now have 3 inverse functions we can use to get a variable by itself when it's inside of a sine, cosine, or tangent function to start. As always, enjoy your day, and we will look forward to seeing you for our next lesson.